So today we'll be talking about Ampere's law. Ampere's law, which has to do with magnetic field strength. So we have that the single loop integral of B, which is our magnetic field, dot dl is going to equal to mu 0, which is a constant, times I. Now this may seem familiar to Gauss's law, which has to do with electric fields, which has the double integral of E dot dA is equal to Q over epsilon 0. Now the way epsilon 0 and mu 0 are related is that 1 over epsilon 0 times mu 0 is equal to c, the speed of light. So we have Ampere's law. Now what does this mean? Well, let's say we have some wire. We have some wire that has some current that is running through it. And what we're going to do is that we're going to draw an imaginary loop around this wire that goes into the screen as well as in front of the screen. So if you imagine it's a loop something like this that goes around our wire, we'll say it's some distance r away from the wire. So it's going to be a circle around the circular wire. And what we find is that when we do this, we have that the integration of B dot dl is just going to equal to B times 2 pi r. In this case, 2 pi r is going to equal to the length, or namely the circumference of our loop that we've drawn around this wire. And the reason why we can put B as a constant here is because we know that since our wire is circular and our loop is also circular, as long as we're the same distance away from the current, we're going to experience the same amount of magnetic field strength. So we have B times 2 pi r. And now, by the law, this is equal to mu 0 times I, and thus we find that B, the strength, is going to equal mu 0 I over 2 pi r. And this is our expression for B. Now what we find is that if I is constant, we know that mu 0 is already a constant, so that just leaves us that B is going to be proportional to 1 over r, which is going to be the distance we are away from the wire. So what we find is that as r increases, namely as we move farther away from the wire, as we move farther away from the current, our magnetic field strength will decrease. So the farther away we are, the weaker the magnetic field will be, which also makes sense. So here's our expression for B. When we have a single wire, like so, with a current running through it, and a loop.